Thanks, Milad, and thank you to Layer123 for the opportunity to be here at the 360 Degrees Network Automation Congress. Good morning, good afternoon, and good evening to you. I'm Roy Chua, principal and founder of EbitThink, an analyst firm focused on technology infrastructure. I'm going to be discussing the journey from automation to autonomous and how we're all trying to orchestrate our intended outcome. I have 20 minutes, so there's no way I'm going to be able to cover the entire topic sufficiently. Fortunately, this conference will run for another day and a half, and there's lots of experts who will take you into detailed discussions of some of the topics I'll be touching on today. Before we look at the topic of network automation, let's talk about networks. What we've seen is an explosion of network locations. They certainly cover a lot more places than they used to. From public 4G and 5G networks to private 4G and 5G networks, from networks in public clouds to networks in private clouds, and now networks in the edge cloud as well. Networks across wide area and into branches and campuses. The scope of networking has always been big, and it continues to expand, especially going from the physical to virtual across multiple domains. Concurrently, we're also seeing a trend towards disaggregation. That's primarily driven by the need to increase the velocity of network innovation. Network disaggregation also comes with multiple benefits. Number one, it brings increased choice and technology innovation. It also provides for service and business model innovation. Disaggregation also enables and helps drive multi-vendor collaboration, well, potentially. Right? It gives network operators a lot more flexibility while potentially avoiding lock-in, and ostensibly should lower costs as well. Unfortunately, network disaggregation also brings about higher coordination cost. When you combine the expansion of the network scope with this ongoing trend in disaggregation, you have a much more complex problem. To meet the challenges, we have to bring in network automation. Human-centric manual processes are not going to work, are not going to scale. On the other hand, network automation, done right, will allow us to deploy and validate and maintain the network at scale. It should allow us to detect anomalies for improved security. It should also help ensure the availability and reliability, all the while through updates and configuration changes, and will help us identify potential bottlenecks. Network automation should reduce the cost of operating the network through enabling zero-touch and also supporting day one plus network ops to assure the end user experience. Finally, network automation can leverage the APIs in those network devices to drive consistency in configuration and enable innovation. Network automation holds so much promise, but unfortunately, the journey there isn't a walk in the park. Let's take a look at our abstraction of the journey there. You may have your own preferred view. We'll start with no automation, which is where just about everyone starts with. That's just manual labor, right? Typing in commands one at a time, right? From there, we migrate to using scripts. And these are simple scripts that are often triggered by users, right? Just starting them. They are created primarily to avoid the laborious task of typing in commands over and over again, often used privately. Now, as we progress in the journey, we see the sharing of these scripts into libraries. Different people can now use them. These scripts might even be templatized so they can be applied in different contexts. From there, we move to orchestration, where we enable complex workflows across multiple domains, handling the dependencies, the sequencing, reacting to the telemetry and feedback, and forcing ongoing checks. We're now looking at things from a service level abstraction as opposed to a device level abstraction, maybe even moving up into multi-domain services. From there, we realize that to scale, we can't take a purely imperative approach. We need to take a declarative approach, We decide what state the network needs to get to, what the end state for the application and components need to be, and the system on its own figures it out. How the network needs to be configured to achieve the goal, that's up to the system. Once the goal is achieved, then the system ensures that it stays there in the face of perturbations. From there, we move into autonomous networks with the assistance of AI and machine learning. The network should then be able to adapt on its own to the changing conditions to achieve the goals that we set for it. However, achieving these self-organizing, self-driving networks will require more work and lots of AI and ML training and experimentation. And with the arrival of 5G and edge computing, we're now moving from thousands to tens of thousands to hundreds of thousands of elements in the network to be configured and to be monitored and tweaked. And therefore, the only hope we have is to rely on an autonomous system or a system with AI ops that provides AI assistance to help scale us humans. As we said, the journey will be arduous and there's many challenges. I'm going to list some of the challenges that we commonly hear on this slide here. We have a ways to go in our journey, but I can say that we are making progress. One key challenge is inadequate skills and expertise. Network engineers still need to move into a different mindset and take a programmatic approach to their roles. Also, because we have historically not been able to communicate clear ROI, and by the way, there's a panel on this at the end of the day that I'm moderating, so stay tuned. But regardless, there's been an underinvestment in network automation. Further, there's been a lack of industry standards around network automation and inconsistent models and interfaces and APIs, as well as a lack of supply of vendor-agnostic tools. Many network equipment vendors have their own network automation suites that work great with their own products, but don't interact with third-party devices. Nevertheless, what we're seeing is efforts from organizations like Etsy, with Etsy ZSM, and Linux Foundation are starting to bear fruit. Finally, to get to our dream of autonomous networks, we need a lot more runtime and experience on today's AI and ML models. Now, let me share my thoughts on what we're seeing in our own engagements with service providers, vendors, and enterprises. A big positive for network automation is the arrival of 5G and edge computing. Both the executive and technical management now realize that due to the sheer number and diversity of network elements, there's no choice but to invest in network automation. That's a good thing because it acts as a forcing function across network equipment providers and service providers alike to both build, design, and deploy systems with network automation in mind. Hyperscalers already saw this as they built out their own cloud data centers. But now across the board, we're seeing an uptick across the entire industry to invest in automation. With private 5G networks and on-premises edge computing, we're also seeing enterprises and system integrators, SIs, prioritize automation and also network automation much higher than they would have historically. Further, what we're seeing with 5G service differentiation and this network slicing concept, it's creating the awareness around the importance of end-to-end experience and quality of service. There's now recognition that network automation will play a key role in enabling this type of quality of service. Further, with recent nation-state hacks and compromise of network security elements, there's a now more proactive mindset towards installing, monitoring, telemetry, creating network abstraction layer to protect the direct configuration and management of network devices. By putting a network automation-enabled RBAC, role-based access control layer, with a robust audit trail, that should increase the security of network. Much more important now than it was before, right? This same abstraction layer can provide increased reliability and resiliency too, allowing fast, safe changes and rollbacks as needed. The importance of this has been underscored by recent high-profile outages, right, at both Tier 1 carriers and hyperscalers. Now let's move on to the process category. Related to this reliability driver is the move to full automation and reliance on a DevOps-style approach to managing the network. Many organizations are now starting to forbid direct network changes without automation. Although recent surveys show that only somewhere between 7 to 10% of large organizations are doing so, we expect this adoption of full automation to increase. To drive the consistency, reliability, and accountability we need, not to mention the agility, this transition is a must. There is also now a movement towards NetOps or NetDevOps, where network engineers understand the need to be more like the cloud application engineers to build an orchestration pipeline. And related to that is we're noticing that this is not just tied to network operators, but the network equipment manufacturers themselves are rolling out their software in CI/CD processes. They are now launching frequent releases, much more frequent than before, directly into test labs at carriers, where these software are validated by automated suites, and then they get pushed out from there all the way into production networks at the carriers. This pipeline that we're seeing, spanning from the telco equipment manufacturer to the carrier, this movement is quite promising. Now let's move on to AI Ops. That's a work in progress. It's promising, and there's a lot of efforts around it, and around where and how it can best assist humans in terms of proactive observations, suggested changes, optimizations. It's certainly a step towards fully autonomous. All right, let's move on to where things stand with regard to tools and standards. On both commercial and open source systems, I have to say things are getting better. Test suite management, workbenches, improved automation, and orchestration solutions are getting out there. And on the standards bodies front, ETSI's ZSM, Zero Touch and Service Management, which you may already have heard about from the pre-conference presentations, as well DMTF, Redfish being used for infrastructure as an infrastructure API, mostly compute, but I'm also seeing that expand into networking. So some of these efforts by ETSI, DMTF, Linux Foundation, with these efforts, the hope is that there'll be more consistent approaches to configuring systems and managing these entire systems. Likewise, on the API and schema front, we're seeing at least a coalescing around Yang, OpenConfig, NetConf, ResConf, and GNMI. There's work to be done for sure, but when major vendors like Cisco and Juniper are now rolling out support for these things, it certainly helps with market momentum and uptake. And on the open source front, speaking of, there's ongoing efforts in orchestration automation. Many of these initiatives are helping facilitate network automation by showing best practices integration and programming network devices. Linux Foundation Networking's ONAP, ETSI's OSM, MCO or ONAP for K8S, ANUCAT, formerly CNTT, are certainly key efforts on this front. All right, let's move on to the culture category. On that side, we're seeing an improvement in the automation mindsets for certain. We're seeing new roles in site reliability engineering to network reliability engineering. These new roles, with increased visibility and cool titles, help drive reskilling and upskilling of existing network engineers. It certainly helps with employee retention, just as Google's SRE role helps spread and create excitement around reliability. NRE, the role of network reliability engineering, can be a clarion call to a new class of talent. All right, now let's move on and take a look at the market adoption of network automation. Where are things at? This slide is a summary and amalgamation of our observations from talking to service providers, enterprises, networking vendors, as well as colleagues and counterparts at other analyst firms who continue to run surveys to understand where things are. We'll start with where automation is being adopted. Unsurprisingly, the highest rate of adoption for network automation is in data centers. As data centers get scaled up, and as cloud providers increasingly consolidate their whole deployment of large hyperscale data centers, it's unsurprising that network automation is needed to operate these at scale. Next up is the WAN, where automation makes a lot of sense, obviously, due to the distributed nature and the number of locations. Part of this is also driven by the SD-WAN movement, software-defined wide area networking, which brings a cloud-based management plane with a unified API across a large number of branch endpoints. In some ways, the SD-WAN cloud controller is network automation on steroids for thousands or tens of thousands of sites, right? It has been very successful, and the API-based provisioning for these sites or these locations, especially at carriers rolling out SD-WAN, have been quite popular. From there, we go into the service provider mobile network and the core, and beyond that, Wi-Fi networks, which in recent years have also moved to be cloud control at least in enterprise deployments. And then after that, we have the campus and the LAN, which are usually the red-headed stepchild in network automation, unfortunately. And finally, SP edge sites are just coming up, and so we expect more automation as they solidify. Let's move on to talk about the next line, which is the who is adopting network automation, right? As we just discussed, cloud providers certainly lead the way, especially hyperscalers. They are used to thinking about building at scale, and automation is automatically part of their vocabulary. Next come the telcos and MSOs, who have embraced some of the elements of automation in their OSS and BSS systems, but who also need to update their practices to be more agile. Think NetOps, NetDevOps, AI, ML, right? After that come the enterprises, led by those with multiple remote sites like retail, the financials, even state and local government. Surprisingly, healthcare is more of a laggard, but that's along with EDU and oil and gas, and then finally the other enterprise verticals. Let's move on to the what. In terms of the type of network automation that's being adopted, most of it, as you can see, is just simple config management. Then there's using on-device automation or existing device APIs. And then beyond that is monitoring and telemetry systems being rolled out. Less common is the use of an SDN controller or even the use of SDN northbound APIs for any type of programmability and automation. As we've discussed, intent-based systems and AI ML are still mostly in infancy across the ecosystem. And finally, at the end there, we have this IAC, or infrastructure as code, sort of a template-driven full-stack deployment from the application down to network configuration. We expect that to have more uptake over the next few years as we see applications deployed with some form of quality of service guarantees. All right, switching gears, let's look at the drivers behind network automation initiatives. This has switched recently to be more security-driven than scale-driven. More companies are now pushed to deploy telemetry to find network anomalies and to create an abstraction audit layer based on the recent breaches and attacks that we talked about earlier. Reliability is also a key driver given the high-profile outages that we've seen, with network automation engineers starting to adopt test before deploy approaches like those in application deployment pipelines. And then strategies like A/B testing or canary testing approaches can also be used or adapted into networking. Now, certainly scaling continues to be an important driver, and we're seeing an increased interest in the quality of experience and end-to-end provisioning with 5G and the edge. So we expect that category to become more critical driver over the next few years. And with that, I'd like to wrap our brief flyover on the state of network automation. If you have any questions, our contact information is displayed. I enjoyed spending time with you and hope you have as well. I hope you enjoy the rest of today and tomorrow at the Layer123 360 Degrees Network Automation Conference. And don't forget to join us for the Business Benefits ROI panel later on today. Thank you very much for your time and have a good day. Bye for now.